Hi there. Thank you for clicking on this video. I wanted to quickly go through projectile motion and how we can apply our quadratics knowledge to those particular kinds of application problems. I am aware that these are not physics numbers. They are friendly numbers to make this a little bit easier to follow. Over on the left, we have height as a function of time. Height is being plotted on our y-axis and time is being plotted on our x-axis. So each ordered pair is going to be time on the x and height on the y. If you are asked for the starting height of the object, you are going to be looking for the y-intercept. Well, how do I know that? Because the y-intercept has a t-value of 0. If I click on that, we can see that that is the point 0.08. So when time is 0, that would be at the start. The height, h, is equal to 8. So we would answer the starting height is 8 feet in this case. You could be asked something to do with the maximum height or the time it takes to get to the maximum height. And for that, you would need your vertex. So anything that says maximum or highest, that's your tip off that you're looking for the vertex. Now, there are two questions you might be asked. If you are asked, what is the maximum height? Well, remember, height is being plotted on the y-axis. So that will be your y coordinate. So the maximum height for this object is 9 feet. You could also be asked, how long did it take to get to the maximum height? And that would be your x coordinate, because time, how long, is on your x-axis. So what this point tells us is that after 1 second, the object is 9 feet off the ground, and we know that is the vertex. The third question you might be asked is, when does it land? And if you picture your object starting and arcing up and then coming down and then hitting the floor, the ground, whatever it's landing on, you would be looking for when the height is 0. Well, since height is on the y-axis, we're looking for where y is equal to 0. That means it's our x-intercept. And in this case, it would take 4 seconds for the object to land. What's great about projectile motion is that it's very, very visual. You can see it on the graph, and there's just a limited number of things that you would generally be asked to answer with that. You can answer these questions using a graph, or you can use your algebra skills like the vertex formula or quadratic formula once you know which points you're looking at. So I hope this helps break down some projectile motion problems for you so that the next time you see them in class, you'll be better equipped to answer those questions.